Hello everyone and welcome to Human-Computer Interaction course. In this series of workshops we're going to be working on Android development and here right now I'm showing you a small introductory part to the Android platform. So I hope it's going to serve you quite well when it comes to if you are not quite familiar with the platform itself in terms of development, of course. Okay. So let's carry on and go to the first slide. So what is actually Android? Android is an open source operating system that's built by Google for mobile phones, tablets, TVs, and quite recently as well game consoles. It was initially developed by Android Incorporation and Google actually purchased it in 2005. Now, Google actually has been developing it secretly until it released it later on, somewhere in 2008, under the Apache license in the AOSP Android open source project. Now, you can actually develop Android applications using C, C++, and Java. And in the bottom here, as you can see, you get this is Ouya, a very kind of promising game console, which actually is going to be released for $99. It's one of the kind of, how can I say, first of a kind, almost first of a kind, that's a serious game console based on Android, and it has its own market and everything. By the time of this recording, it hasn't been released yet, but although you can purchase it if you want to. This is the Nexus series. This is Nexus 4, Nexus 7, and Nexus 10 tablet. And this is the NVIDIA Shield project, or NVIDIA Shield game console, which is, as you can see here, it's completely based on Android, and you can hook up a TV, HDMI to it, and it can stream a very nice up to 1080p high definition image, which is an amazing thing, and it has NVIDIA Tegra 4 processor, as far as I remember, or as far as the presentation went of their demo. And as you can see here, also you can tell from the look of it, it's quite fragmented market, which is quite famous word that people usually, when they come to Android, they usually talk about it, because it's fragmented. What it means by that is the development for, let's say, Ouya, which is hooked up to a TV, is completely different for programming something like a mobile device or a tablet or a 7-inch tablet or a bigger 10-inch tablet, or completely different than this little guy over here, this Project Shield, which has a small screen, in which when you hook it up with a TV, it becomes a completely different thing. So this is one of the difficulties which people usually have when they program for Android, in contrast with other platforms like iOS, for instance. Also, it's one of the but iOS as well, how can I say, is it started to have this fragmentation by, for example, right now the previous versions of iPhones that had a constant fixed 3.5 inches screen until iPhone 5 by the time of this recording came out, and you get a little bit larger or taller screen accommodating more pixels. The iPad mini and the iPad normal iPad 10 or 9.8 or 9.9, 9.5 inches tablet, plus as well the retina displays that it comes with it. So you get with retina display versions of the iPad, so you get the old iPad didn't have it, and then I don't know, starting from the 3rd generation or the 4th generation, they started to have the retina display. So so basically iOS got as well started to get this kind of fragmented way of developing. However, Android still widely used, and it's actually one of the, if not the right now, the dominant mobile platform in the market. So it comes with its, how can I say, drawbacks as well. So you need to when you are programming, you need to know whom you are addressing, what devices you are addressing, so it will make your life a lot easier when developing your application. Okay. A little bit of history. So in 2005, Google buys Android company, and then on 2007, the Open Handset Alliance is announced, and the Open Handset Alliance is a sum of like 80 something companies or 90 something companies, including Samsung, Motorola, HTC, and mobile carriers like T-Mobile, AT&T, and so on and so forth. And all of them, they gathered in order to, they formed this Open Handset Alliance that are supporting the Android platform. From 2008 through 2010, Android becomes the dominant mobile platform in the market, and 2011, Android start to invade tablets, game consoles, TVs, and so on and so forth. Okay, so what do you need to develop for Android? Now you need now in terms of operating system, you don't need actually to worry about it. Either Windows, Linux, or Mac will do. You can actually use an IDE such as Eclipse or NetBeans, but basically we are going to use Eclipse. And yes, you're gonna need the latest version of Eclipse. You're gonna have to be really up to date, because most of the time you are most of the time the platform and the Eclipse itself gets updated, and there are a lot of bug fixes, and sometimes it fixes a lot of issues that you probably could suffer from. So it's a good idea that you keep yourself up to date, of course. The Android SDK, of course, you need that. And after installing both, now there is an old way of installing the Android. How can I say, or preparing your computer for Android development. You install the SDK, and then you install Eclipse, and then you install manually the ADT Android development tools plugin for Eclipse. Or you can actually, and it's quite recently has been released, the Android bundle, where you just simply download the zip file. I'm going to show you on the link later on by the end of the slides. I'm going to show you it's a very neat way. Just simply download the zip file. It's like 400 megabytes or so. It has the latest SDK. It has the Eclipse as well, pre-configured, and everything pre-configured for you. You just simply need to extract it, run it, and run Eclipse, and you are set. Okay, now it is throughout this course, basically we're going to develop against an emulator. We're going to be having an emulator all the time. However, it is much better, and it is very good to have a real Android device for development. If you consider seriously for working on, if you're seriously working on, you consider working on Android development, then you're gonna really need an Android device you're gonna test against, because you cannot test against the emulator and then publish your project. You're gonna end up with a lot of problems. So you're gonna have to test your project against a real device and against other devices. If you have a friend who has a different kind of device, just test your application on. As well as the real Android device, it allows you to tap into the sensors, and then you can test stuff. So if you are your application uses accelerometer, gyroscope, or GPS or something like that. However, GPS, okay, it could be faked. You have a feature in development called, like, you can actually insert your own GPS data just so you can test it. But with the accelerometer, is really difficult, so you're gonna have to really get yourself a device for that. And yes, there are other softwares that taps into the emulator to simulate an accelerometer, but again, my advice to you, just get yourself a real device to test these sensor values. Okay? Alright, so since we know this, you need to know what is actually you are working with. So for example, when you are firing up your device, once you connect it to your USB, or you have an emulator, your Android, the Eclipse, in fact, it communicates when you run actually the application. It sends your application to your emulator or to your phone through something which is called the Android Debug Bridge, ADB. Now, without it, actually, you cannot, how can I say, you cannot debug, or you cannot actually install or develop your application. So you're gonna really need ADB for that. And then, thank God, it comes built in with your SDK, so you don't need to worry about that. If you are interested, you can in fact go ahead and see it for yourself. So I prepared for you a couple of links, and you have the Android debug bridge, and you have the target as you have actually the command list uh, of ADB. So in case you would like to go through the command prompt and manually deploy an application or manually connect to your device, it depends what you want to do. So but technically we're gonna be using it one time or another, so we're gonna see that later. Okay, now going up next, let's see the Android versions and their APIs. Now for you have like some sort of a 3 columns or 4 columns here. This one you can simply ignore right now because this is by the time of recording, and I actually copied it from the Android developer website. So just don't look at this for now because this one is regularly updated. The version number is kind of nice. It's for you as well to know. It's good to know. The code name is also good for you to know. But the API is the most important thing that you have to know. Okay, so before, of course, Donut, you had Android 1.5 and then Android 1.1 and so on and so forth. But it was ignored because nobody, I mean, because these were like some sort of the initial releases and nothing was fancy about them yet. Now, you have as well, by the time of this recording, we reached to the latest Jelly Beans. And as well, if you notice that Google is keeping the Android operating system name against or named after desserts. And also, amazingly enough, they keep it alphabetically ordered, so D, F, G, H, I, J, you see? So donut, eclair, froyo, gingerbread, honeycomb, ice cream sandwich, jelly beans, and I don't know, there was another operating system that was rumored after jelly beans, key something cake, I cannot remember, so it has K as well at the beginning. Anyway, when you are developing, you have to take care whom you are targeting. So basically you have to target the latest greatest. You have to target the latest version. So anybody who buys the new phone with the newest operating system, your application has to be there as well and working for them. However, you cannot leave people out who are the old users. So you're going to have some sort of backward compatibility, or not basically backward compatibility in that sense, but basically you have to support the older platforms as well. So the question is here, how far you should get. Now this question is answered by the distribution, and I'm going to show you a better way of looking at it. I'm just put here the table for you here so you can see the API numbers and what you have to take care about. Okay? Alright, now we're gonna address this table in a different way later on when we get to the Android dashboard. Now let's go ahead and talk about the Android stack. Now the Android stack is very important to see because it will tell you how the operating system is constructed, and you will know when you are developing, when you are tapping in your application, you know where you are tapping in and how the stuff works. Now at the base of the whole stuff is the Linux kernel, and the Linux kernel is being used here. By the way, the kernel, it's not the whole Linux, it's only just the kernel. It's just that 1.5 or 2 megabyte file that's responsible for allocating memory and managing resources and all these stuff. This is only that part. There's nothing else about it, no other things that are attached to Linux. Let's say the X system for windowing system and all these stuff has been completely thrown out. Now people have been using Linux kernel for 2 major reasons. Reason number 1 is that it is relatively secure, because right now people actually know the security model, so it is secure basically. The also second important thing, and if not even the more important than the security model, is that in Linux kernel we know the driver model, which means that we know how to port Android for all devices, which is actually the philosophy of Google. Google would love to see Android running on everything, in your fridge, in your washing machine, in your mobile phone, in your TV, in your consoles, and it's actually happening right now. I mean, the only thing which in Android hasn't invaded until now is the household items, probably, as far as my knowledge goes. Right now, you have the Google TV. You can buy it from Sony, and you can use your phone even as a remote control for that. So you go and check it up. Just Google for Google TV, and you'll find Sony that made device specially for that. Your phones, tablets already exist, and you have already consoles that are rolling into the market quite soon, that are going to be relatively competitive with these giants, with the Xbox and PlayStation 3, in my opinion, probably. It's going to be quite interesting to see how this battle will go. All right. So that's why people are using. So that's why Google has been utilizing Linux kernel in order to build this operating system. Now, coming up next, you get the set of libraries that are a bunch of how can I say, legacy projects that has been done like before, and they just simply has been put right there into the operating system. So OpenGLES, I don't know, SQLite, libc is the responsible for if you would like to write applications using C and C++. So I believe this is libc is actually the one which is responsible for it, and so on and so forth. Now the only thing is which is new, in fact, is the core libraries and the Dalvik virtual machine, and we're going to talk about that in the next slide, especially about the Dalvik virtual machine. Now, coming up next is your application framework, which is basically your API number. So this API is actually this part, okay? It describes how the system will expose itself to you, because you are sitting right here. You are, as an application developer, your application just sits here, communicates with the API, and everything just passes down right there. Now, by the way, the security model of Android is quite interesting, because the kernel decides, basically, it has the final say what's going to happen. So you basically, whatever security call you're going to do, it just pass down way until down to the kernel, and then the kernel will decide, am I going to allow you to do that or not? Which is actually kind of good, because for instance, if you are if you look, for instance, at BlackBerry, I believe, or Berry kind of phones or platform, you are actually developing using Java, and your and the security model is actually handed to Java. So you are not allowed to program in any other language other than Java. Okay, C, C++, all these stuff has been locked. So, so the coolest thing about Android is that you can actually program using C and C++, you program using Java as well, without hindering or without, how can I say, jeopardizing the security of your, either the operating system or the application. Okay? Now, let's go ahead and see how your application is compiled. Now, if you look here at the top part, you get your application is this is how your application, your regular Java application is how this actually is compiled. So basically, you send your Java source code, goes through a Java compiler. The Java compiler compiles it into a Java bytecode, and then your Java bytecode actually runs on your Java virtual machine. This is what exactly happening. Now, of course, your Java bytecode is being compressed, you know, into some sort of a zip, which is called a jar file, and then your jar file being copied into the memory and then just extracted right there, and then your Java virtual machine starts running it. Okay, now if you look here on the bottom, this is how your Android application is being compiled. First of all, your Java source code is being going to a Java compiler, compiles it into a Java bytecode, which generates a bunch of class files like here, and then your class files is actually going through a Dalvik compiler, which compiles it into a Dalvik bytecode, and then your Dalvik bytecode is gonna run later on the Dalvik virtual machine. Now, Here are actually a couple of questions that may pop up, or may you may ask yourself, like why on earth Google actually went into the trouble and making its own Java virtual machine, and also if for any kind of crazy reason that okay they made it, why they didn't go from Java source code right away to Delphic bytecode instead of going through this additional step. Because as you look here, as you can see here, you can easily actually drop this out of the process and just simply send your code through a Delphic compiler, gets compiled into a Delphic bytecode, and then later on when your application will run, it will run into the Java virtual or Delphic virtual machine. Now, first of all, Java Virtual Machine is uh, not optimized for mobile devices. It is really, really resource intensive, and it's really slow as well. So, I mean, okay, this is my personal opinion, but basically, Java Virtual Machine is really resource intense. It will overheat your CPU, and it will consume a lot of battery power, which is completely against the idea of being Android as a mobile platform. So this is one out of the way. Another also problem is that Java Virtual Machine, or Java in general, is owned by Oracle, and buying a license or licensing such a virtual machine, or such a platform for mobile, and then distributing them and running them on all devices in the same way that is happening right now, it would be completely and totally expensive for Google to pay for all that. So what Google said, okay, we're gonna actually build up our own virtual machine, and this virtual machine will be completely optimized for mobile, and it will work just fine to you know to elevate the problem of using a lot of CPU and a lot of battery power, and as well as get away from all these licensing problem. And so that's why you get all these right now, how can I say, lawsuits between Oracle and Google because of that virtual machine. Now, the next question which I would like to answer is why the Java source code has been compiled into a bytecode then Dalvik code instead of just jumping onto the next jumping from Java source code into Dalvik bytecode. And basically what you can see here is that you can have not only Java source code, you can have any kind of programming language that if it can be compiled into a Java bytecode, it can actually run into, it can be compiled into a Dalvik bytecode and then run to your virtual machine later, which is actually happening right now. You're gonna find a lot of popular books and a lot of articles about how to write, right now, how to write C#, pure C# applications. I mean, native C# application. You're writing, you know, C# code for native Android applications. So you can program a whole Android application using just C#, which is kind of amazing. So basically, people have just done a small, how can I say, interpreter or a compiler that just simply compiles into probably Java bytecode and then pushes it into Dalvik bytecode. You have as well a library for games called MonoGame. It does also pretty much the same thing. You get all your applications just compiled into Java bytecode and then goes into a Dalvik bytecode. Also, one of the how can I say, pros of Dalvik bytecode is that Dalvik bytecode is actually compressed. It's really compressed. It has a very small files, smaller than the Java bytecode after compressing even. I mean, this guy is completely uncompressed. And I mean, by the way, your applications in Android is not being like, how can I say, it's not compressed into a jar file or anything like that, because basically basically the Android way of addressing resources is kind of a different, because for instance, your phone actually has RAM, of course, and has the flash drive, and the flash drive, which is inside your phone, it has already some sort of a similar speed to your RAM. So when Android application addresses your resources, they don't copy it to the RAM anymore because you don't have much of it. They just simply say, okay, I'm just going to point to the object on my hard drive as just I point to a resource in my RAM, and this is what's exactly happening right there. So basically your application is compiled into an APK file, which is extracted later on into your system inside, and it just all these files laid down uncompressed there, and your operating system will just simply link to them or point to them as if they are already exist in the RAM memory, which is kind of cool. Okay, now next is how your final application is compiled. So your application is compiled, of course, into an APK file. So basically you get a bunch of Dalvik executables, okay, which is your Dalvik dex files, plus your resources, okay, and native libraries if you have it, okay. So if you don't have it, native libraries means that you wrote something in C, C++, plus your Java stuff. So all of these three will equal to APK, make up your APK file. If you don't have any native files or any C, C++ libraries, so for example you wrote a physics engine for your game or some sort of high-speed mathematical calculations that you would like to run it in a high speed using C, C++, if you don't have that, then just your resources, which is anything which is not code, like your images, sound, whatever, icons and all these stuff, your layouts, your forms and all these stuff are actually being resources. So your Dalvik executable plus your resources makes up your APK file. Okay, now last but not least, last slide here is your very important links and resources that you have to know, and this is very important for you. You please keep these links bookmarked or just keep a browser session saved just for these stuff, okay. And I will show you each one right now. So before developing your application, you have to choose which API you want. So we need to go ahead and check out your dashboard, okay. So by the way, before I go into that, this is the Android SDK. Right now you can just simply download the ADT bundle for Windows or for whatever operating system, I believe, but because probably it detects that I'm using Windows, so it gives me that. So what you get is Eclipse plus the ADT plugin, the SDK tools, the platform tools, latest Android platform, and the latest system image for an emulator. We're gonna be actually not using the built-in Android system emulator because last time I used it was a little bit kind of a slow one. So I'm using something which is called Jar of Beans. I'm gonna show you later on in the next lesson when we start programming. And it's for free. It's a portable emulator. You can just simply copy paste it and extract it anywhere, and it will just double click on the exe and it will work. So it's gonna be fun. So this is where you get your Android SDK. So developer.android.com/sdk/index.html, and then you get your stuff. Now the Android dashboard. By the time of this recording, this is the current distribution of how many people is using or are using the operating system versions. So for now, you get the by the way, it's updated every 14 days, okay. So right now, as you can see here, very few people actually use the Eclair and older, which is like 0.2 or 1.9%, so let's say about 2.1% or something like that. A little bit of Froyo, so 7.5% of the market are using Froyo. 43.9% people are using Gingerbread. Ice cream sandwich is 28.6%, and jelly beans is right now 14.9%. So this is a very good graph, tells you how far you should go back to support the market. So if you support jelly beans, you support ice cream sandwich, and honeycomb, by the way, is this Google attempt to support or to work with tablets, but then later on it introduced a lot of problems, and because the concepts of mobile and tablet weren't unified, so they just simply introduced ice cream sandwich, which unifies these two worlds, and everything just took on from there to jelly beans, of course. So if you support jelly beans, ice cream sandwich, and gingerbread, so you have to go way back until gingerbread, and you are actually technically supporting about 75 to 80% of the market, which is kind of good. which is the thing which you need in order to get more money for the development time you put. Okay. Of course, you could be suffering from code that has been deprecated, and Eclipse will throw out warnings at you. This code has been deprecated, but of course, you're gonna have to use it because you are supporting older APIs. Okay. Now, going to because we are, of course, Human Computer Interaction course, you're gonna go and see the design concepts, how to design applications for Android, and you're gonna have to, for example, make sure that you follow the guidelines. And by the way, when you are programming for mobile platforms, it is not the same as programming for your large, beautiful screens of your computer, because everything has to be really pixel perfect, because the phones are really closer to the user's eyes, and you really need to make sure that the user doesn't feel awkward when he uses your application. Any one pixel disalignment and the user will suffer from problems. And as you can see here, here is the UX guide, which is user experience guide, how to lay out your application appropriately for your phone, tablet, and for whatever resolution you have. Okay. Now, please remember, this is applicable only to Android. It's not applicable for iOS. iOS has its own UX guide. If you are programming for iOS, then you just simply do not look at this page. You look at iOS, because every platform, every operating system has its own philosophy and mentality for its user interfaces. Okay. So please consult the user experience guide for the platforms which you are developing on. So if you're developing for GNOME on Linux, they have their own UX guidelines, and if you are programming, I mean, this is for Ubuntu and stuff, or GNOME in general, not only Ubuntu. If you are developing for Android, this is the page for you. If you are developing for Windows, you have already the Windows UX guide, and it's PDF. It's already or exists on the internet. Just Google for it. And you have for Mac their own UX guide, and for iPhone their own UX guide. So please consult the UX guides which you are for the platform which you are programming against. Okay. Now, going ahead, you need to know the tools of the trade. So you need to know your tools, which is right there. This is your developer tools, your ADT, and you can download them separately. You can see their help and just, you know, like explore and read in case you would like to have interesting or whatever feature you are hunting for. And of course, everybody loves tutorials. So if you would like to go through a tutorialized way of building your application, there you go. This is a very interesting set of how can I say, step-by-step tutorials of how to create your Android project and work on from there. Now, if you would like to start working on advanced stuff way beyond the hello world applications, then you're gonna have to reference to the API guides, and it's really interesting. You have everything you need in order to develop for you know, for Android in general. So if you would like to tap into the sensors, so here you go. You have the accelerometer, ambient sensors, gravity. If you would like to extract it alone, you have the magnetic field, which is the compass part. Gyroscopes, temperature. There are a lot of applications or a lot of hardware that are hardware phones. I mean hardware, actually mobile phones and tablets that has actually a temperature thermometer kind of a sensor in it, and it tells you with code snippets how to program with it or how to program against it and use it. Now, if you have time and if you would love actually to explore this as a business, you can actually start working on accessory development, where you can in fact build your own hardware and put Android on it. Okay, so you can do your own intelligent house, and you can put on your hardware, and then whenever you get into the house, just simply clap with your hand, and then the lights will turn on and do your own stuff. So this is kind of interesting for people who are making their own hardware and just putting Android on it. You have the I believe the kit can be bought, and you have already the PDF somewhere that you can buy the components on your own and then build it on your own. And by the way, the page which I skipped in is the API reference in case you would like to go really deep inside and learn how certain things are working and what are certain classes and what their functions and their documentation. So this is the SDK documentation if you are interested in. So this is comes for the this is it for the API reference, and this is it for the kit, Android or accessory development kit. Okay, and I believe this is the open source project. If in case you would like to play with the Android as an operating system, you know, tinker with it a little bit, you need probably to have a Linux operating system. It will be easier for you to start compiling and playing with the Android platform itself. Probably you can come up with your own fork project based on Android, so this is actually up to you. And this is the Android NDK, Native Development Kit, and this is used, and this library or this NDK generally is used for if you are programming Android for Android in C or C++. So this is the library which you need to address. And by the way, this is not going to be the focus of this course. We're going to be using only Java. This is, if you are interested, feel free to explore. This is the webpage for the SDK, and you have documentations as well there, and all these details are for you. Okay, and this is the Android Debug Bridge webpage if in case you needed to have some sort of documentation for the command prompt. If you needed help on something or certain commands you would like to do through an ADB, feel free to consult this documentation. All right, so I believe this is it. I have explored with you basically almost all the resources, and of course, please, Google is your friend, and Stack Overflow is full of people who are asking the same questions you are asking, and people already answered a lot of them there. Honestly, I usually don't like reference books, so these two books are really small, really good. Creating Android Applications, developed and designed by Chris Haseman, is a very good book. And Learning Android by Marco Garganta is also an excellent book on the subject. And you can see Marco Garganta's series on YouTube on Android development, and it's a little bit long, like 28 or 29 videos, I believe, series, and every video is like ranging from 1 to 2 hours per video. But it was an Android, some sort of Android bootcamp it's called, and it's kind of interesting to see as well. And sometimes I personally go and refer to the series from time to time to see how he actually approached certain problems, which is kind of interesting to see from a professional as well. So I believe I covered basically all the resources which you could need in case you are stuck in Android development in general. I personally consult all these resources which you have, so I hope it's going to be a good help for you. And thanks a lot for watching. See you later on the next lesson, and we're going to start on we're going to boot up Eclipse and start writing our first Hello World application. So see you in the next lesson.